see you come in. Today, we're going to talk about statics. What exactly is statics? Well, it's quite simple. Statics is the branch of mechanics concerned with bodies at rest and forces in equilibrium. Statics are governed by three rules, which were discovered by one of the greatest physicists, mathematicians, and a fellow Englishman, Sir Isaac Newton.
What's up? So, Newton's three laws. The first one is, an object in a state of uniform motion stays in that state of uniform motion unless acted on by an outside force. For example, I'm just sitting here and there's no forces acting on me, so I'm going to keep sitting here. The second law is, the force is equal to the mass times the acceleration. The acceleration of me, again, is just gravity. And the third law is, for every action, there's an equal and opposite force. So, technically, you never lose in a fight. You'll just tie.
Hello. When dealing with statics, the sum of the forces always equals zero, meaning that they are always in equilibrium. To simplify calculation, objects are treated as particles. They have masses, but no specific size or volume. This means it does not matter where the forces is applied on any object.
In statics, objects are considered rigid bodies. There are no deformations in the object. The object is made up of particles, and these particles are separated by a fixed distance before and after forces are applied. There are different ways to apply a force. A concentrated force is acted on a single point versus a distributed force that acts on an area. When dealing with larger objects, a concentrated force is a better assumption than a distributed force.
Let's talk about massless objects. In some calculations, it's okay to omit the mass of certain objects like rollers, pins, and cables, because the true masses of these objects are far less than the forces acting on your object. Let's take a tension problem, for example. As you can see here, there is a mass suspended from a cable. Now, when we're trying to determine the tension force of the cable, we don't care about the mass of the cable because it's negligent. It doesn't matter. All that matters is the mass and the acceleration of your object.
Let's talk about how to set up a statics problem. First thing we're going to do is draw a coordinate system, so we know whether or not our forces are negative or positive. The second thing we're going to do is draw a free body diagram of all the forces. Now, it may seem silly to draw such a simple diagram, but it helps keep all your calculations neat and organized.
Moment forces are a little tricky. A moment is a measurement of the tendency of a force to rotate an object around a point or axis. The moment force is determined by equation as shown above. M equals R times F sine theta, where M is the moment, R is the distance vector, multiplied by F, which is the force, times sine theta, and theta is the angle between the forces. If the vectors R and F are perpendicular, then the sine theta would equals 1. So therefore, all you have to do is multiply R times F to get the moment.
Signs of moments. In statics, we define counterclockwise as positive and clockwise as negative. To determine signs, we engineers use something we call the right-hand rule. You take your right hand, point your fingers along the distance vector, and you curl your fingers towards the force vector like this. And if your thumb comes out of the board, it's positive. If it goes towards the board, it's negative. And yeah, that's pretty much statics.
Let's briefly talk about friction forces. Now, on a perfectly frictionless surface, if I pushed my colleague Eric here, he would just shoot straight off the edge. However, as you can tell, it takes me a substantial amount of force to actually keep them moving at a constant speed. This is because, well, for a lack of a better term, little nubbleys are preventing Eric from sliding straight off the edge.